Hi there guys. Now in this video we're going to have a look at turning points, and what we mean by that is like a minimum or a maximum point. So we've got two types of graphs that we're concerned with. There's quadratic graphs, they're parabolas that look something like this or like this, and we identify these when we're looking for this x squared term as the leading term, the one at the front. Okay, and we have cubics, but we'll come on to those in a minute. So quadratics, there's two types. They can be happy quadratics, look something like that, and we can have sad quadratics. So it's meant to be quite a nice smooth curve. Now, if it's happy, we can see that easily because the number, the coefficient of the x squared term is positive. And if we have a negative coefficient, something like that, is going to look like this. So we would say this point here is our minimum point, and this point here would be our maximum point. But please be aware, they can look like this. So the minimum point is not always on the y-axis, it can be just the lowest point of our quadratic, and the same thing goes for this one. But it's really important to identify these coefficients to know what the graph is going to look like. Okay, cubic graphs. The highest power is x cubed. I'm going to try and draw my best x cubed graph here, so bear with me. Okay, that's not too bad. So it's a curvy line, but it starts at this bottom left quadrant, and it comes up, it hits here, and then it comes. In fact, I'm going to draw that again, you'll see why. Okay, that's so much better. And at this point, it sort of fakes. It fakes to come back down, and then it comes back up. Okay. Now, cubic graphs, they can get way more curvy. They can start to look like this. And you can see when it looks more like this, you have a maximum and a minimum. So this confuses people because how can this be a maximum point when I can see points up here that are clearly higher? And likewise for the minimum. So that's why we call them turning points. So this is a turning point, but it's a maximum turning point. And this is a turning point, but it's the minimum turning point. Okay, so it's very similar to the quadratics, but you have two of them. Now, this one doesn't have either. So what we actually call this is a point of inflection. These only happen on x cubed graphs, cubic graphs. Not just this one, we can put some basic left and right translations on it and it will still do this. We can stretch it in the x and y, stretch it in both the x and the y, and it will still do this. Okay. Now, one more important thing to point out. At a turning point, the gradient is flat. It is 0. Okay, all of these turning points, the gradient is 0. At this point of inflection, where it comes up and actually fakes to come back down, it continues in the same direction, it's actually 0. And likewise, oh, that's pretty shocking. Let me do that again. There we go. So this is all to do with when we find our derivative, we're going to put our derivative equal to 0. Okay, so that will give us the location of where the gradient is equal to 0. All right, so let's start having a look at some functions. Let's go in the deep end. Let's take this one here. Oh, not even on the pen. So let's take y equals 2x cubed plus 3x squared minus 36x plus 1. So it's a pretty difficult looking graph. Now it's x cubed and it's a positive x cubed, so it's going to go like that. Oh, I didn't say that earlier. I'll just do that now quickly. But if it's a negative x cubed, instead of starting here, it's actually going to start here. And it's going to come down and then turn. Okay, so that's a really important thing to note. But this is an x cubed, so we're expecting it to look something like this. Now, when there's a bit more going on, like squared and x, that's when we get this nice curvy looking graphs. Okay, so everything's in index form, so we're good to go. Let's find the derivative. So it's going to be 6x squared plus 6x minus 36. Okay. So to identify this point and this point, like I just said, the gradient's actually going to be equal to 0. So it's really good to write this line in here, turning point when dy by dx is equal to 0. Therefore, 6x squared plus 6x minus 36 equals 0. Okay, so I really did go in the deep end. I started with a cubic graph. My next example will be quadratic. You'll see it's much easier. But you just now have to solve like we did before. In all the previous videos, when we found the derivative, when we put it equal to something, we solved it. But in this instance, we've now got a quadratic. Excuse me. So I'm going to factorize this, but before I do that, are these terms, do they have a common factor? And yes, they're all in the 6 times table. So what I'm going to do is divide everything by 6. And you'll see that has now made my life so much easier to factorize. Okay, so there's nothing common to each term. Just like to point out, it could be one bracket if there's something common. X squared, factors of 6, 3 and 2, that make the 1. So it's plus 3, take away 2. We can say x plus 3 is equal to 0. We can say x minus 2 is equal to 0. Therefore, x is 2. And x is negative 3. Okay, so that means, let's just make a quick sketch here. Oh, no, that's horrendous. I'll just pause it and I'll draw it quickly. Okay, so that's a little bit better. Let's put it's good practice to always, well, you should always do this, because you need to show that it's a graph with y and x. Okay, so at minus 3, let's just say it's there. This is what a sketch is. Let's say 2 is there. So it's going to be accurate. The points that I'm going to be showing are accurate, but they're just not to a certain scale. So at the moment, we know it's going to turn here. We know it's going to turn here, but where? So we've got to actually find the y coordinate. So the only way we're going to do this is subbing it back into our function for y. So I'm going to start right over here, and hopefully it doesn't overlap this one, the one on the right. So we've got 2 lots of minus 3 cubed plus 3 lots of minus 3 squared minus 36 lots, and it is going to overlap, minus 3 plus 1. Okay, so you have a calculator, so you can type this in. A really lovely way of typing this in, though, is putting minus 3 into your calculator and pressing equals. And then using your A and S button, it's next to your equal button, it's your previous answer button. So you could type in 2 answer cubed plus 3 answer squared. So instead of putting a minus 3, you press an answer, and your calculator will follow BidMath and give you the answer really nicely. So, but I'm going to do it old school. So that's minus 27 doubled, that's minus 54, plus 27, eq, that's plus 90, 108, plus 1. And if we tidy all that up, we get 82. Yeah, that's right, 82. Which at first glance it makes me think, wow, I've got it wrong. So let's put 82 up here. So there we go. Okay, let's do the same. I'm just going to change colour because I'm worried it's going to get messy. So y equals 2 lots of 2 cubed plus 3 lots of 2 squared minus 36. This is the bit that makes it annoying, the 36, but hey. So that's going to give us 16. 4 times 3 is 12. Minus 72. Add 1. And just tidy that up. And we get minus 43, I believe that is. So let's put a minus 43 there. And that's going to be that coordinate here. Okay, so how do we sketch this? So just have a quick look. We've got a constant value of 1, so that means that's going to be 1. This is a positive, so we know we're going to be starting in this bottom left-hand quadrant. And the first one I'm going to get to, if you think it's going to have to go like this, the first one I get to is going to be my maximum. So it's going to come up. Let's try that again. It's really hard on these graphic tablets to do this. All right, look at that, it's not bad. It's going to come through that point, love that. Oh, it's going horribly wrong. You'll be able to do a lot better job than that, but it's coming up, it's coming through our wind step, it's coming down to our turning point, and then carrying on. Okay, I'm conscious that this video is getting on a bit now, so I'm not going to show you any more, but this is the worst case scenario when it's a cubic. When you differentiate, you're going to get a quadratic. If the function is quadratic, you're going to get a linear, what am I trying to say, derivative, and it'd be much easier to solve, much easier to draw as well. Okay, so have a practice, use your answers, make sure you get it. Good luck.